Now we're going to take a look at the rules that are here in the yellow box, and we possibly could even extend that yellow box so that it included all three of these rules. Because the division one also is there. The only one that we really haven't been talking about yet is the bottom one with negative exponents. But when we look at this rule, when we take a look at this rule, it kind of acts like a distributive property type thing. This exponent on the outside of this parenthesis kind of sort of gets distributed in to multiply times both of these. And when that happens, I end up with 3 to the third and a to the second to the third. And because it's kind of distributing, it actually ends up being multiplied. So 3 to the third, again, if you want to go through and write that number out, 3 times 3 times 3, that's fine. 3 times 3 is 9. 9 times 3 is 27. But I'm more worried about the fact that you realize that this kind of distributes in. And so I've got the a to the 2 times 3, which is a to the 6th for an exponent here. Number 2, kind of, again, doing the same thing. I get 2 to the 4th. And if you are looking and you're wondering, well, how does that become 2 to the 4th when we're supposed to be using a rule? Well, there's a lazy 1 right here, if I can get it in the right place. Okay, so I get 2 to the 1st and then n to the 4th. Okay, it is not 2 to the 4th. Okay, it's n to the 4th and then a 2 to the 1st. So then if I'm using the rule, I've got 2 to the 1 times 4 and then n to the 4 times 4, which gives me 2 to the 4th and n to the 16th. Again, you can write that out. 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. So I get 16 n to the 16th if you actually multiply it out 2 to the 4th. So same thing happens here on like number 6. So I get 3 to the 1 to the times 4. I get a to the 1 times 4. And I get b to the 4 times 4. So 3 to the 1 times 4 is 3 to the 4th. And then a to the 4th and b to the 16th. 3 to the 4th, again, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 gives us an 81, if you wanted to write it out that way. I'm not too concerned about that. That's something you can plug in your calculator. The exponent rule you cannot plug in your calculator with the variables. So when we jump down, let's say to number 9. Number 9, I've got x to the second, and then that was all to the second, y to the second, to the second. So I get x to the 4th, y to the 4th for my final answer. Now number 14, well, when I look at number 14, I've got some stuff inside the parentheses that's already multiplied. So I don't want to do outside parentheses before I do inside parentheses. I still want to follow the rules of PEMDAS that we did in 1.4. So we're going to look at doing what's inside the parentheses first. So I've got 2 times 2 is 4. I've got a p to the 1 here. So p to the third times p to the first gives me p to the 4th. I'm adding those two things together. They're like bases, add the exponents together. And all of that is still to the second power. So now I get 4 to the 1 times 2, and then p to the 4 times 2, which gives me 4 to the second, and p to the 8th, 4 to the second to 16, then I get 16p to the 8th. Okay, using these exponent rules. If you do not practice with the exponent rules, you will not get them. There is no way to get the exponent rules besides going through, trying them, making sure that if you've got like bases, you add the exponents. If you've got a set of parentheses and only one base, you're going to be multiplying the exponents, going through, doing kind of sort of the distributive property with the exponents, and then next we're going to be looking at using those negative exponents. We're going to combine all of these things together to be able to manipulate and simplify these expressions. Let me do one more. Let's take a look at number 15 here. I've got something inside the parentheses again. So I've got inside the parentheses, I have n to the third times n to the second. I've got two bases, an n and an n. The bases are the same, so I'm going to add the exponents. So I get n to the 5th. And then this kind of sort of does the distributive property, 4 to the 1 times 2, and n to the 5 times 2. So I get 4 to the second n to the 10th. 4 to the second is 16, or 4 squared is 16, and then n to the 10th. Okay, practice with these exponents. We're going to be adding them all together. So each, on this worksheet, we did each individual rule by itself. Then we're going to add all of them together so that they're all mixed in, and then we're going to add negative exponents to that as well. And make sure that you're clear about these in order for us to move on.